Hi all and welcome to this EduConnect video. Today we'll be looking at set theory, probability, and Venn diagrams. So the first thing we're going to look at is some notation on how to actually write what's in a set and what it's equal to and etc. So the first thing we need to know is that to notate a set, you have to give it some random letter. So we'll take S for example. It's a pretty generic one for any set S. Now to say what's inside set S, you say equals, and then a curly bracket, and then you can put your numbers in with commas in between them. So let's say we go 1, 4, 7, and 9. Now it's really important that there's always curly brackets here and not any other sort of like the circular brackets or these square brackets, because that's wrong and that essentially is something else. And it's also really important that you have these commas in between the numbers, so that it's really clear that it's not like 14 or 147, but instead it's 1, 4, 7, and 9. Now, the next thing we're going to look at is how to say something's equal to another set. So, say we have another set, which is A, which is equal to 1, 7, 4, 9. Now, the order is not the same as S, but the numbers are. And in a set, it doesn't matter what the order is, because the numbers are always the same if it's the same set, right? And because it's just a reordering of the numbers, it means that these two sets are equal. So what we can do is we can either write S equals A, or we can just make the two sets equal to each other. So we can do this 1, 4, 7, 9 is equal to 1, 7, 4, 9. Now if we change the 4 with a 5, so if you have another one which is, say, B, which is equal to 1, 7, 5, 9, that is actually a different set. So it's not equal. So S is not equal to B, or 1, 4, 7, 9 is not equal to 1, 7, 5, 9. Almost forgot the comma there. So there we go. Now, the next thing we're going to look at, and you can do the same thing here for A, so you can go like A is not equal to B, and then 1749 and 1759. So the next thing we're going to look at is the element sign. So what we're going to do is this sign over here. So that's the element sign. So it's essentially like a curved E, or you can do it like a C and then a line in the middle. Now what that means is, so the numbers, whatever's on the left of it, so if you have an element here, whatever's on the left of it, so that is an element of whatever's here. So for example, if you take this subset, if you take this set S, and we use that element sign, we can go 1 is an element of S, right? Or 4 is an element of S, or 7 is an element of S, etc. Now, there's obviously the opposite one as well, which is not an element of, right? Now, it works in the same way. So here you'd say that, say, 5 is not an element of S, right? So that's basically some basic terminology. We'll look at some more in the next section. Alright, so the next thing we'll look at is finite and infinite sets. So finite sets essentially refer to a set which has a bound. So it starts at a number and ends at a number. It doesn't go on forever until infinity. So an example of that would be odd numbers from 1 to 20. So if we say notate that with the stuff we just learned, S is equal to 1, 3, 5, 7. Now, as you keep doing this, you're going to realize that it's going to be pretty boring if you're going to have to write out 10 separate numbers at once. So what you can do to avoid that is just go comma, dot, 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 comma, and then pick it up from, say, 17, and then 19, and then that's your set done, right? Now it's pretty obvious what this dot 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 means because there's a difference of 2 on each one, right? Obviously, if it's a more difficult one with like weird numbers, it's probably a bit more difficult to use the dot dot dot, but I guess anyway, if there's a sort of a pattern inside it, then you can use it. Now the next thing is an infinite set. So an infinite set is one that goes on for forever. So what you can do is positive odd numbers, so every single positive odd number. Now we don't have an end to that, right? That could go on until infinity. So what we'd do in that case is we'd go 1, 3, 3, 5, 7, forgotten how to count, 7, and then you can go dot dot dot, and then close the bracket. What that essentially means it's going to keep going forever, right? Now, if you want, you can do a bit more to make it more believable, I guess, but that should be fine in most circumstances. So now, the way that we sort of write how many numbers there are is using this terminology. So for a set S, we use this, right? Now, you might have seen this something like this before. It's called the natural value in some methods, when you have like this and go X like that. But this is a bit different. This is in set theory. And set theory likes to be a bit interesting. So essentially what it is, it's 2 straight lines with the letter that represents the set in between them. Now that essentially refers to the number of values, right? So probably should have done a different letter here. So let's say this is Z, right? Now, if it's an infinite set, we can't use this function because we don't know exactly how many numbers there are. If it's a finite set, we can. So for example, in the set S, it's 1 to 19, and there's odd numbers. So there's 20 numbers there, and it's all the odd numbers. So you just divide it by 2, and it's 10, right? Now you could do this for any set just to work out how many values there are. So let's take an example now of a set where there's only one value, right? So say a set A is equal to 1, right? So what this means is there is a set A, right, which has something in there, but there's only one value. What we call this is a one element set, right? So let's say A has the number 7, right? So that means there's only one number, so this is correct. And this is showing us that the only number is 7. Now the most important thing that we have to know here is this thing here does not mean that A is equal to 7. Because A is not equal to 7. The set A is equal to 7. It's a really important distinction that needs to be made. Because A is not a pronumeral. It's a letter that denotes a set. Right? So A is actually not equal to 7. Now, the next thing we're going to look at is when we have a set, right, which has no values. So for some set X, it's equal to 0, right? So the symbol that we'd use is for this scenario is a circle with a cross through it. So that denotes an empty set. So we wouldn't actually use a letter for this scenario. We'd do the 2 lines around this and make that 0, right? And the way we can confirm that there's no values inside of it, we can say for any value X, it is not an element of this set, right? So that's a pretty key thing that we have to know, that this is how you denote an empty set. Right, so the next thing we're going to look at is something called subsets. So a subset is this symbol. So it's essentially an elongated C with a line on the bottom. So what it means is that so the set on the left, so let's say set S, everything in set S is also in set A. So if that occurs, so say we have S is equal to 1, 4, 5, and A is equal to 1, 4, 7, 6, 5, then S is a subset of A because 1, 4, and 5 is also in A, right? So that's a pretty basic way of saying it. Another way of saying it is all S is in A. That makes more sense when we say something else. So say we take birds and owls, or say humans and mammals, right? So let's denote humans as H and mammals as M. Humans are a subset of mammals because all humans are mammals, right? But mammals are not a subset of humans because not all mammals are humans, right? So you can do the same thing here. A is not a subset of S because not all of A is in S, right? So that's a really clear sort of determination that you have to make, and you might have noticed this symbol over here. That's the opposite of a subset, so essentially means it's not a subset. Right. Now the next thing I'm going to look at is what it means for empty sets that we just looked at. So an empty set, if you don't remember, is a set that's denoted like that. It essentially means that there's no values inside, so the way we would notate that is like that. Right? Now, because there are there's nothing in that set, right? This is actually a subset of every single set available, right? So say some generic set L, right? It is a subset of it because everything that's in this empty set is in L, right? Because there's nothing in the empty set. So that's a really important thing that we have to know. It's a really important sort of basic fundamental of this. Yeah. Now, another thing is that the subset also applies to any set that's equal. So if we have another set, so I'll just erase this stuff over here. So we have another set, say M, which is equal to 1, 4, 5, right? S is a subset of M, and M is a subset of S. Now the way I like to remember that this holds true is if we remember this line at the bottom here. If we go back to sort of primary school when we started learning less than and greater than signs, if we have the line at the bottom, that means that it's also true when they're equal, right? So I like to remember it like that. This is also true when they're equal. Well, that brings this video to an end, and I'd like to thank you all for watching this video. Please feel free to like and subscribe, and also comment any questions you may have. If you have any further questions or doubts that you'd like clearing up, please feel free to go onto the EduConnect website, which will be linked in the description, and sign up for one of our free plans, where I'll help you by using video calls to clear up any doubts you may have.